Okay, sir.
Shall I start?
So, 1 second, sir. I will introduce you. I will welcome all the participants and you, sir. Jai Hind, a very warm welcome to Day 20 of Society for Agricultural Advancement, Research, Training and Human Innovation, Knowledge Revolution in Agriculture, Nourishing Technology and Innovation 2026, our 30-day National Agriculture Training Program. On behalf of Agri SAARTHI team, it is my immense pleasure to welcome all participants and our esteemed resource person for today. I am Dr. Vijaya Kumari along with Ms. Chatrisha. We are from the Agri SAARTHI team. We will be coordinating and guiding you through today's session. I take this opportunity to extend my heartfelt and respectful welcome to our organizing director, Mr. Ajay Kasana sir, the Chief Secretary of Agri SAARTHI KRANTI 2026. Agri SAARTHI KRANTI 2026 is not just a program, it is a dynamic movement envisioned by Mr. Ajay Kasana sir to transfer agriculture education in India. Before we move ahead with today's program, let us briefly recall the highlights of yesterday's session. Yesterday, we had the privilege of listening to an insightful lecture on agroforestry for livelihood and utilization of forest product. The session was delivered by our esteemed research person, Dr. Kumar Puni sir. Dr. Puni sir explained the important role of agroforestry in improving farmers' livelihood while ensuring environmental sustainability. He highlighted how integrating trees with crops and the livestock systems can enhance farm productivity, diversify income sources, and promote better utilization of forest-based resources. He also discussed the economic and ecological benefits of agroforestry, including soil conservation, biodiversity conservation, carbon sequestration, and sustainable utilization of forest products. The session truly helped us understand how agroforestry can contribute to both rural livelihood security and sustainable natural resource management. As it is rightly said, the tree meaning of life is to plant trees under whose shade you do not expect to sit. With this valuable learning from yesterday's session, let us move forward to today's topic. As we know, agriculture is one of the sectors most closely linked with climate and weather conditions. Variations in rainfall, temperature, humidity, and extreme weather events significantly influences the crop growth, productivity, and farmers' livelihood. Therefore, understanding and adapting to these changing climate conditions has become more important than ever before. As the famous environmentalist once said, the environment and the economy are really both two sides of the same coin. If we cannot sustain the environment, we cannot sustain ourselves. Today's topic, climate smart techniques for the future of agricultural meteorology, is extremely relevant in the present era of climate change. Climate smart agriculture focuses on improving productivity, enhancing resilience, and reducing greenhouse gas emission while ensuring sustainable food security. Agricultural meteorology plays a crucial role in this transformation. By integrating weather forecasting, climate data analysis, crop weather relationship, and modern technologies such as remote sensing, decision support system, and early warning system, we can help farmers make better and timely decisions. Climate smart techniques maybe include weather-based crop advisory services, climate resilient crop varieties, efficient water and nutrient management, precision agriculture techniques, agroforestry, and sustainable land management. These approaches not only help farmers cope with the climate variability but also strengthen long-term agricultural sustainability. As Norman Borlaug, the father of Green Revolution, wisely said, agriculture is the foundation of civilization and any stable economy. Therefore, integrating climate science, with agriculture is essential for securing the future of training. Now, it gives me immense pleasure to introduce our esteemed resource person for today's session, Dr. Yogesh Kumar. Dr. Yogesh Kumar is currently serving as the Assistant Professor of Agricultural Meteorology at Chaudhry Charan Singh Haryana Agriculture University, Haryana. He is dedicated scientist and academician with strong expertise in agrometeorology, climate smart agriculture, crop simulation modeling, and climate change adaptation in agriculture. Dr. Kumar completed his MSc in 2025 and PhD in agricultural meteorology in 2029 to 2019 from Chaudhry Charan Singh Haryana Agriculture University. His doctoral research focused on simulating potato cultivator responses to different planting dates using the substar potato crop model, highlighting his strong research background in crop modeling and climate introduction. Before joining CCS HAU, Dr. Kumar served as a subject matter specialist in agrometeorology at ICAR NDRI Krishi Vijnana Kendra, Karnal, Haryana from 2019-2023, where he actively contributed to farmer advisory services, research programs, and capacity building initiatives. Earlier, he also worked as a senior research fellow in the Department of Agricultural Meteorology in the same campus. Dr. Kumar has received several prestigious recognitions during his academic career. He was a recipient of the Australian Award Fellowship by the Department of Foreign Affairs and Trade, Government of Australia, and was also honored with a Young Fellow Award at the Global Meet of Science and Technology for Food and Nutrition Security in 2019. In addition, he also successfully qualified the ICR ASRB net multiple times. In terms of academic contribution, Dr. Kumar has an impressive publications records with 33 research papers, 3 review papers, 1 book, and 4 book chapters, along with more than 80 popular articles and several extension publications. He has also actively participated in numerous national and international conferences, seminars, and symposiums. Apart from research and teaching, he has also played an important role in organizing scientific awareness events such as Earth Day, World Environmental Day, and Agriculture Education Day. Dr. Kumar is also actively engaged in science communication and media outreach. He has delivered expert talks on DD Kisan, several regional television platforms, social media forums, and YouTube channels, as well as radio programs, where he spread awareness about climate smart agriculture and weather-based advisory services for farmers. With such a vast experience in research, extension, and farmer outreach, we are truly fortunate to have him with us today, so to share his valuable insights on climate smart techniques for the future of agricultural meteorology. On behalf of the entire organizing team, I extend a very warm welcome to Dr. Yogesh Kumar sir. Sir, we are honored to have you with us today. I now request you to kindly deliver your talk and enlighten us with your expertise. Over to you, sir.
Thank you so much, Dr. Vijaya, for detailed introduction and all the information pertaining to me from my educational background, my professional career, and entire information that is given to the participant. And I'm really thankful to your convener, Dr. Ajay Kasana for giving opportunity to express my view. And at that internationally platform, that is Agri SAARTHI KRANTI 2026, it's an fortunate to me to share my experiences, to share my knowledge and wisdom to your participants. Hope all the participants will get some more useful information from environmental science, from the terms of agriculture meteorology, in terms of AI and climatic science, how that all the data, how that meteorology will influence our overall agriculture and production, and what are the different techniques they can overcome at the farmer field level. So we can start our topic with permission of your participants. And can I audible and visible promptly?
Yes, Doctor, everything is working. You may please start the presentation.
Thank you, Doctor. Thank you. The presentation is visible, sir?
It is yet to be shared, Doctor. Please share.
I have shared the presentation in the slideshow. Is it visible now?
You please share from the share button, Doctor. Initially you have did, then you have to repeat those steps.
Now is it visible?
Yes, Doctor. Please make it to full screen. Okay, great. Please start. Thank you.
Can we start, sir?
Yes,
So,
Doctor, please.
So, good evening, everyone. Again, our today's topic is climate smart technique for the future of agriculture meteorology. As we all know that there are several types of climate smart technique which are employed in the farmer field, and there are also act as a barrier for improving the overall soil fertility and increasing productive production at the farmer field level with these techniques. In today's topic, we have covered almost all the technologies that are pertaining to the climate smart agriculture scenario. And we have initially start the question. The big question is, how do we feed everyone? As we know, there is an increasing compulsion of increasing population that will exert more pressure our put more pressure to the overall production of our entire Indian continents. As we know that up to the 2030, we have reached up to 1.5 billion. That population we can feed up by nearly 10 billion of population with exerting the same pressure on over land surfaces, over different kind of crops we are growing at the farmer field. The main challengeable issue we are facing in our Indian conditions, the majority of the farmers are small and marginal farmers. Those farmers who have land holding size is 2 to 3 acre, mostly the farmers have that land holding size. So we have to enhance their farmer field productivity at that small or marginal farmer to meet out the hunger of each and every population that is reached up to the 10 billion by the 2050. In addition to that, we have also faces there are several types of climatic challenges like heavy rainfall, flood-like situation, drought. Every year there are up to the 25 to 30% crop losses we have generally observed due to that climatic challenges. So in our major scenario, we have to feed everyone at our farmland with the production of the quality produce, with the use of recent technology, with the use of recent climate smart technique, with the use of AI and machine learning technique. And we have to adopt that changes, that climatic risk changes with the use of AI. We can discuss in details about in our presentation. The main rational studies of that kind of climate smart technique is you have to feed everyone, and particularly in your entire scenario and Indian scenario also. So what are the major obstacles in our farmer fields today? That Indian conditions have received almost 1,200 mm rainfall over the entire Indian conditions, but majority of the Indian conditions will receive up to the 800 to 900 mm rainfall during the southwest monsoon season. Is it their unpredictability and early onset and delay onset of monsoon will always create chaos in your stable, sustainable production system of all the crops. That may be the erratic behavior of monsoonal rainfall. Sometimes it will onset up to the 8 to 10 days early onset. Sometimes it will delay up to the 10 to 15 days. If you discuss the last year scenario, the monsoon onset will be early onset up to the 7 to 8 days in entire countries. So we can decide that scenario in terms of your all the sowing of your kharif crops. Same kind of situations we have observed in our groundwater scenario also. In terms of Haryana condition, in terms of India conditions, if the fluctuation in monsoon rainfall will, we have witnessed that kind of monsoon or erratic rainfall behavior, it will ultimately affect our underground water resources or underground water scenario also. The same kind of scenario we have observed in pest and diseases attack. If the temperature is much higher and is accompanied with high humidity, that will it will attacks the majority of insect pests, mostly in sucking pest. If we discuss an example of cotton crop, cotton jassid and cotton aphid, if the rainfall is intermittent rainfall we have observed in farmer field, there is a sudden increase in the temperature along with the rise in RH scenario. If RH is within line that 80 to 85% with the onset of heavy rainfall, there is a severe prevalence of cotton jassid and cotton aphid in cotton crop. So that kind of crop losses we have witnessed, that will damage up to overall your cotton crop up to the 80% losses we have observed in farmer fields. The same kind of scenario you can also see in sugarcane. Sugarcane, if the sugarcane top borer attack, if your RH high, there is low rainfall, that scenario will also trigger the huge population of sugarcane top borer. And by just over span of single night, it can damage up to the 70 to 80% your crop by that insect pest. Similar kind of soil health, if we are using the imbalanced use of fertilizer, we are did not test our soil and water testing centers, and unbalance all the things will directly or indirectly hamper our environmental systems, our sustainable production system. These are the major obstacles we have witnessed in our field farms that we can manage through the different techniques of climate smart technologies, and there are several ways we can meet out or we can minimize the losses with the help of that AI and agriculture meteorological technologies. So what we are doing for that kind of smart work, we have to work smarter, not just harder. As I have earlier said, in traditional area, what our farmers generally do, they just sow the crop and harvest the crop just without incorporating the latest technology, without incorporating the suitable agronomic technological interventions, without incorporating the recent balanced use of fertilizer, balanced use of profitable farming system technologies. So, what are the major lacuna in traditional farming and today's farming is we have to adopt that smart farming technologies. We have to adopt that digital agriculture technologies that brings your third green revolution. In that smart farming, we have to use our resources precisely. We have to use each and every available resources in a perfect way, that we have to gain much more natural resources, and by using the zero drip irrigation, several technologies you have to use precisely, with the use of GIS, with the use of GPS, with the use of drone technology, with the use of remote sensing, with the use of climatic smart intervention, with the use of climate smart agriculture. in a predictable way. Like if your model suggests sometimes we have predict the harvesting yield of any crop, ki that that coming season is more suitable for the rice crop instead of you are going to the cotton crop by the Planning Commission of India, by the Government of India, Ministry of Earth Science will suggest that the upcoming monsoon season is not so good. So you can plan your crop plan should be managed according to the forecasting system. So you can predict that crops that is having low water requirement. By using that crop, you can manage your available resources in a profitable way. So the smart farming is the main motive by three P's. One is precisely use your natural resources, precisely use your available resources in a productive, predictable way in terms of your monetary output. By the farmer can get some monetary benefit in terms of their smart farmings. So the major shift is from not from guesswork to the data driven sections. Means you are not working in it just like a tukka or just like you are guessing the upcoming weather conditions and saying ki that may be the behave upcoming climatic condition, that may be that kind of climatic condition may be the prevail. No, that's the IT yug, that's the AI yug, that's the machine learning traditional upcoming generations. We have witnessed that Gen Z's, that is data driven decision, traditional ways not accept precisely. We have to work as per the data driven decision that is given by the different models, that is given by the different technologies. We have to use that technologies for working smarter, not just harder. So we have working with the data, not just for guesswork like Andaza. We have to collect the data, then analyze with software, and then decide and act precisely. We have to discuss in the upcoming slides how you can collect the data, then how you can analyze the different software programs, and how that software will decide your crop planning as per the prevailing climatic conditions, prevailing your soil conditions, prevailing your crop management conditions, and finally, what are your main outcomes from your farmer fields, and in terms of your profitability, and in terms of your actual yield production from traditional to the smart farming data sets. So these are the some basic informations. What is the climate smart agriculture? As we have already discussed, the main aim of CSA, we have to increase our productivity. We have to strengthen resilience to the climate change. Resilience means we have to cope up with that climatic shocks. We have to cope up with that climatic stress that is each and every crops and varieties we have witnessed in our farmer fields in terms of their heavy rainfall, in terms of their dry spell conditions, in terms of their uh, flood and drought like situations. We have witnessed so many climatic stress or shocks we have observed in farmer field. We have to develop that resilience to tackle that kind of climatic stress with efficiently without deterioration in overall your agricultural productions. And we have to generate that greenhouse gas emission technique like carbon sequestration, carbon trade, carbon smart technologies, from where we can minimize the greenhouse scenario or green or global warming potential of different greenhouse gases like carbon dioxide, methane, and different types of CFC and other gases. So, what are the different climatic smart practices? That may be the precision agriculture, that may be the irrigation schedulings on the basis of IWP upon CPE, that is irrigation water. On the basis of your cumulative panel operations, we can go for the crop diversification by the amalgamation of forest trees, horticulture crop, vegetable crops, and those varieties which are much resilient toward the climatic changes. We have to adopt that different kind of digital agriculture tools like AI, machine learning, and Internet of Things. So we can get different ideas by using that conservation agriculture, climate smart agriculture with climatic science data. Means you have to act in a cyclic way with the use of data driven science along with your climate smart agriculture. How the data driven science will integrate that agriculture meteorological fundamentals in climatic smart agriculture. It's a new era of data driven science from where we can move the traditional climate smart agriculture towards the carbon smart farming with the association of data driven climate smart agriculture. So these are the earlier we have you have read out in several books there are three pillars of CSA: productivity, adaptation, and mitigation. We all know that we have to increase our production. Productivity means you have to increase your production in per unit area by the using of GIS, GPS, and remote sensing. If we combined three terms in a single way, we call it geospatial technologies. And the main aim of geospatial technologies by CSA to enhance your productivity at each and every farmer's field by increasing their productivity of different crops. Second one is resilience. I have earlier told about the resilience. We have to we have we have to enhance your capability or we have to cope up or strengthen our existing varieties, existing crops that are more susceptible towards that climatic stress, towards your climatic shocks by the adjusting your sowing dates. You have to alter the crop management strategies. You have to alter their different climatic smart technologies by the enhancing your resilience at the farmer field. There are generally you have discussed the two terms mitigation and adaptation. I have in simple terms we generally understood mismatched both the definitions. Mitigation means try to do something reduce. That is a mitigation. Mitigation means we have to reduce a certain components from an environmental systems. For example, if we say we have to reduce the concentration of CO2 from an environment. In I think in today's scenario, the actual concentration of CO2 is 450 ppm. You can search out by the E.CO2 concentration at each and every day variation of CO2 by daily calculating the current level of CO2. The current CO2 concentration level is 420 ppm of CO2. If we try to do that, reduce that concentration of CO2 by adopting different kinds of mitigation strategies like carbon sequestration, that is a types of mitigation. That means we have to try to do something reduced by CO2 using that carbon sequestration. Or we can use that carbon trade by adopting the trade protocols of IPCC and trade protocols of different organizations. So these are the generalized terms you have studied many times in your UG courses. What is adaptation? What is mitigation? Adaptation means we have to adapt, we have to resilient that upcoming abnormal weather conditions by facing that abrupt or that is against the unfavorable environmental conditions by to minimize their negative impacts and enhance their positive impacts. That is the adaptation, that is the resilience, how you can cope up that against any climatic shock or any climatic resilience. So these are the three pillars of CSA. These are the several technologies which are assisting in climate smart agriculture. First, that is climatic monitoring. As you know that IMD is already installed more than 720 automatic weather stations throughout the India, from where we can get the continue about daily. We have received 96 observation. At the 15-minute interval, we can receive more than 100 observations from each and every automatic weather station throughout the India. That all data we have received in NDS National Data Center in IMD Pune, from where you can get the entire climatic database we have saved over there, and we can get the information about the real-time weather informations for your tactical climate smart farming decisions. We have generated the short range weather forecast, nowcasting, medium range weather forecast, and different types of weather forecast that is issued by the IMD, state meteorological centers, and district meteorological centers. They are incorporated in as a smart tool to give the on farm farmer advisory in the form of climate smart agriculture. Second, remote sensing and GIS by the different types of satellite imagery, that may be the visible satellite imagery, that may be the infrared satellite imageries, different types of NDVI map. NDVI, that means normalized different vegetation index. It's a differential band of NIR and IR that will provide the values from 0 to 1, that indicates the spectral band from where you can give a brief uh, give information about your health of the crop in terms of your spectral reflectance, means how your vegetation will behave in terms of your values of spectral reflectance of NIR and IR. If your vegetation value shows that zero point 0.6 to zero point 0.8 value of NDVI, that means your crop is in robust conditions. That means your crop looks healthy vegetation. You can monitor your crop health without any contact, without visiting your field conditions. You can broadly analyze your data in terms of your rice and wheat area estimation and crop health estimation. These all types of climate smart agriculture technique you can generally estimate using the NDVI and remote sensing and GIS derived different kinds of map. Third vision is machine learning and AI. We can discuss in details in our upcoming slides how you can prepare your yield prediction models with the examples of our station data. How at my station data we can generate that different kind of yield prediction models. You can also generate that data sets from your location from where you can study in your UG program, PG program, and PhD program. You can also dump your own station models. You can also dump your climate risk prediction models, and you can also use that a long-term data set. Like in our conditions, we have generally used 1980 up to the 2025 data set, long-term data set, and we have analyzed that set assets, and we can develop a yield prediction model. I have seen in our upcoming slides. Next is precision agriculture technologies. You have used that VRT, smart irrigation system like FIRBS, furrow irrigated ridge base system. By using that technologies, by using that climate smart technologies, you can optimize your input use efficiencies in terms of water, fertilizer, pesticides, and you can improve your efficiency at farmer field level. Then Internet of Things based sensor systems that include soil moisture sensor, temperature sensor, nutrient sensor. These all the IoT based systems will assist in climate smart agriculture in our data driven smart farming systems. Then nowadays everyone is talking about the modeling. You generally heard about the crop models. You can different type of crop models you have seen in your different literatures by your UG program, PG program, and PhD program. Someone saying that model is more efficient for the prediction of the crop yield. You can use DSET model. DSET means decision support system for agrotechnological systems. Someone uses FC model, agriculture production simulator system. Someone uses aquacrop model. Model is a set of equations that mimic the actual the crop scenario or actual behavior of your cropping system. That is a model. Model will mimic the actual crop growth of your each and every steps of from their emergence to the up to the physiological maturity, you can derive different types of multiple regression equations in terms of crop models. That is a model, and there are several types of crop models we have developed by the different institute. One of the widely used model is DSET model. It will calibrate it up to more than 52 crops, and there are several models you have witnessed in our scientific fraternity. Yeah, if you discuss about Indian conditions, our IRI, Dr. Pramod Kumar Sura, PK Sura, and Dr. Pramod Kumar, Dr. Agarwal has also developed the infocrop model in our Indian conditions in IRI, in Division of Environmental Science. They have developed that model. It will also calibrated our different types of our field crops, and that more than 50 to 20% their yield reliability we have witnessed in that models. The main purpose of crop models, we have to simulate our crop growth under different climatic scenario to act as a different crop management decision at farmer field level. It means by without you have cultivating your crop, you can grow the entire crop in a computer models, and you can predict that varieties overall yield and suitability of that crops, suitability of that variety in a new area without doing any experimentation. You can grow that crops in different areas. That is the main aim of your crop simulation models. That is the entire scenario will depend on the data driven agriculture in terms of your climate smart agriculture technologies. That is the most boon to the humanity if we more focus towards the crop simulation models, if we more work out on different kind of models in different locations, multi-location yield trials we have generated, that will ultimately it will enhance their applicability of that models. So, as I have earlier told, there are several models. These are the computer-based models that mimic the crop growth, development, and yield under different weather conditions, soil conditions, management conditions. These are their calibration and validation model. Means these are the certain parameters that is required for the minimum data set required to run any crop models. These are the some basic criteria, some basic inputs we have required if you run any crop models. If you have run that models, you have required this certain climatic inputs, temperature, rainfall, soil radiation, humidity of that regions, the same kind of soil information, that same kind of crop practices, the same kind of management practices. Like if I'm also working on different kinds of model during my PhD and MSc thesis. Firstly, we have generate different types of, of minimum data set required to run any crop models. Minimum data set required that all the informations. After that, you have to calibrate it. The model calibration means you have to readjustment the all the parameters to maintain a hierarchy just like a real crop growth conditions. After that, you have to validate that results with the farmer field data. Suppose your model gives an output about 25 quintal per acre of any wheat variety yield prediction, and actual conditions that may be differ from the 15 quintal per acre. That means there is a significant difference about than 10 quintal per acre. That means you have to re-evaluate all the data that you have entered in our crop models, and you have to cross-check the data and re-enter all the information again, and after you have to evaluate the actual field condition with your model derived values, and then final outcomes when you received at your farmer field level, then you compare the actual field conditions and your computer or your model derived values with the farmer field. If your accuracy of that model is less than 15%, that means your crop is overestimated by the models. Your crop is in excellent condition. You can use that model in different varieties and different locations. That is most suitable model for your doing the further researcher and help the farmers to tackle their climate smart intervention at farmer field level by incorporating their seed rate, by incorporating their fertilizer level, by incorporating their nitrogen content, by incorporating their crop management tactics, by incorporating their irrigation and fertilization levels of different at the different phases. So there are also some other interventions you can incorporate in your CSA based technology, that may be the index based crop insurance. You can also, different insurance agencies also use that to assess the risk management strategies by using the CSA approach. You can also use that CSA techniques in crop diversification by amalgamation of forestry plant, by using the orchard, by using the vegetable crop production, by using the horticulture, by using the silviculture, by using the in traditional rice wheat system. You can incorporate as a moon crop, and you can inculcate different types of crop diversification techniques with the use of CSA. You can also use your weather forecasting technique as per the climatic advisory by making the crop weather calendars by the DHO, by the district agriculture officers, by the agriculture departments. Each and every aspect will enhance your data driven agriculture by proving the climate smart agriculture practices in terms of their enhancing your agriculture productions. So the major idea from where we can generate that the CSA will integrate the technologies, not the traditional technology, by combining the traditional technology to with the recent technology by the incorporating the climatic informations with the use of climatic smart agriculture technologies. Overall scenario, when we use our agriculture to making more profitable, more productive, and more precisely uses our available resources at farmer field level by making our agriculture to more profitable, from where farmer can get much higher income in terms of their production, in terms of to minimize their crop losses and enhance their pro- productivity in terms of monetary input, mainly profitability. So these are the essential technique we have used in terms of weather smart agriculture. You can use the application of weather forecasting, like what varieties we have selected that is more promising for that region, that more promising that upcoming weather conditions, that more promising to that terrain of climatic scenario. What is the actual optimal depth saving? What is the tentative their harvesting dates? The second point, you can also alter by the northwest, and I have given an example of that region. The majority of the farmers that will go for the sowing of wheat crop up to the 3 to 4 centimeter depth of in generally sowing of that crop, by deciding that depth of sowing. Generally, the planting window of wheat crop in northwest India is 10 to 25th November, and harvesting date of normally in northwest India of wheat crop is 10 to 25th April. Both the both the planting and harvesting dates that is hampered by the majority of the rice wheat cropping belt of northwest India due to the late harvesting of the basmati rice crop scenario. The farmer will go for the burning of the rice residue in terms of their late harvesting of that rice crop. So they have lesser time period for their sowing of that wheat crop. So by adopting that weather forecasting, by adopting that weather smart technologies or weather smart advisories, they can plan their sowing and harvesting window of wheat crop, saving from the late onset of sowing and protection of their wheat crop from the terminal heat stress at the time of reproductive phase in wheat crop. In current situations, we have witnessed there is the majority of the wheat crops, they are facing terminal heat stress condition in late sown wheat crops. So by application of weather forecasting, by application of different types of data driven climatic smart technologies, you can plan your planting window and harvesting scenario up to the 135 days to 145 days normal time period of wheat varieties will lie that scenario. Same kind of you can plan your fertilizer and pesticide application. Same kind of application of irrigation management. Generally, 4 to 5 times of irrigation generally required for the irrigated wheat crop by the farmers. Same kind of we can plan your extreme weather events. Similar kinds of we have used at storage and post harvest management. There is also we in earlier slide we have already told about weather smart. Farmer have to be oriented towards the weather smart in terms of weather forecasting because it is a key tool in terms of their climate smart agriculture. Same kind of scenario in water smart agriculture technologies. By adopting rice crop majority, you can use alternate wetting and drying conditions, but pertaining to that area where there is a limited water availability, from where that is the major constant we have seen, like underground limited water underground water facility is there, and their prolonged dry spell may be prone towards water stress conditions. Then farmer use that water smart agriculture technologies to save water and also to reduce the methane emission, because in puddled rice, when you can puddle your rice crop in traditional systems up to the 1 month or up to the 1 to 2 month, when you flood your entire nursery in terms of your irrigation, it will release majority of the methane from the traditional paddy puddled field in rice crop. It will enhance your greenhouse gas emission, and ultimately it will enhance global warming potential of different greenhouse gases. By adopting water smart agriculture technologies, alternate wetting and drying, you can minimize your water and you can also reduce the methane emission. Same kind of scenario you can GIS, you can use the precision land leveling by the minimizing the uniform your entire field level by the using laser guided leveling of fields to create uniform conditions by the application of your fertilizer, application of your different insecticide, herbicide, pesticide, each and everything you can minimize in terms of balance level by enhancing your nutrient use efficiency, by enhancing your fertilizer and insecticide use efficiency. Each and every aspect you have judiciously used, and you can enhance your efficiency of different agrochemicals also. Same by adopting your DSR also, by the tensiometer. These all are the technologies that are pertaining to the water smart agriculture technologies in terms of your data-driven science in climate smart agriculture technology. From entire scenario, what is the key insight you have received from that part? Means you have to efficiently use your water management technologies. That is the best way to get your climatic adaptation in agriculture at farmer field level. I have many times saying at farmer field level. That means the entire technologies that will applicable at the farmer field level, because if each and every technologies that are contributing at farmer field level, that means you can directly enhancing the resilience of the farmer field level, that is will and directly enhance the farmer resilience to increase their production, to reduce their cost of cultivation. that will ultimately increase their production, ultimately increase their profitability of small and marginal farmers. The main lacuna is enhancing their cost of cultivations. That is why farmer could not get the sufficient production at farmer field level. So we have to intervene that climatic smart technologies that will help the farmers at farmer field level. The same scenario will continue in carbon smart and nutrient smart agriculture by adopting the carbon smart technologies. But these technologies require a lot of agricultural mechanized field that is mainly applicable for the heavy farmers or those farmers who have higher land holding size, that is more than 10 acre per 10 acre, or that is more prosperous farmers. Like zero tillage require a heavy cost, huge cost of their installment. Although there are several benefits we have used in terms of climate smart benefit, that is the save energy, reduce emission, improve soil carbon, and minimize the soil disturbances in terms of their losses of soil organic carbon. If by adopting the zero tillage, by adopting the crop CR, crop residue management, we can integrate integration of legume. By the traditionally majority of the farmers are going rice wheat belt, you can, if you incorporate the moong, it will enhance their soil organic carbon, it will break the traditional system, and it will enhance the soil organic carbon content, enhance your fertility of the crop, and enhance your overall inoculum of soil, environment, and crop scenario, will increase your overall production also. Then there are several technologies we can use. Site-specific nutrient management, that is the green seeker. By using that technology, you can assess the nitrogen content in crop plants. By using the NDVI sensors, you can assess the real-time cropping nutrient monitoring. Means these all are the climatic smart benefits you can get by the adopting that climatic smart technologies. Although I have already told these technologies require a major cost, but if the but government are trying to reluctant to those small and marginal farmers by using the custom hiring centers, by providing the subsidies to the farmers in same conditions in our Haryana condition also there, by adopting Meri Fasal Meri Byora. There is a scheme government of Haryana that is run by the Meri Fasal Meri Bachat. There are several flagship programs that is run by the government of India, government of Haryana, to enhance their by enhance the different kind of climate smart technologies at the farmer field level, by minimize the minimum cost to the small and marginal farmers. They can give subsidy to that heavy machineries, and they can given subsidies to different types of small and marginal farmer in terms of their FPOs, farmer producing organization, by adopting the KVKs, by adopting the CSC centers also. So from there, we can get key idea is climatic smart practices. They can help to reduce greenhouse gas emission by improving the soil organic carbon and enhancing the productivity of different crop. Again, I have already discussed nutrient smart agriculture, green seeker, that will provide the nutrient content in terms of their NDVI, that will provide the information about green reflectance, that will already tells about the what is the health condition of your crop. Is it nutrient stress? Is it their is it climatic stress? Is it their other kind of stress that will show in their reflectance? If the reflectance is within 2 to 4 NDVI value, that means your crop is in stress condition. The stress may be the nutrient stress, disease stress, water stress. That may be the differ by comparing the different conditions. Same types of leaf color chart, you can manage your fertilizer overuse, you can manage the balance use of fertilizers. That same kind of SSNM, precise water applications, fertilizer application, you can use the VRT, variable rate of or technology. By adopting that fertilizer applications, you can use nutrient smart agriculture in terms of data-driven science by the adopting that climate smart agriculture. So these are all the informations I have shared with you. Now we were moving to a little bit in detailed information how that climatic smart agriculture will integrating the weather data with AI and crop models. Firstly, we have given the introduction of different technologies. Then we have discussed the AI technique. Now we have discussed the AI technique in our upcoming slide. Then how we combined all the three things: weather data, artificial intelligence and machine learning, and crop models, and integrating into a climatic smart agriculture technology for future agriculture meteorological techniques. By integrating all the information in a single wizard, how the farmer can adopt the technologies and enhance their production at farmer field. Okay, so how you can integrate artificial intelligence with crop and climatic data. So in traditional crop modeling, we have used a similar traditional data in terms of your mathematical relation, that may be the empirical data, correlation and regression technique in terms of crop weather relationship data. We have we have we have witnessed a limited data set by pertaining to the crop growth, by pertaining to the actual weather conditions, and with very limited resources we have, and the all the data are region specific and crop specific. So we could not get the desired results from that traditional data set. After the advent of machine learning, after the advent of different kind of technologies, now we have a bulky data from the agriculture data, from the climatic data, from in terms of their data set in terms of crop data, management data, soil data, crop management practices data. Each and every data set now we have on our fingerprints in terms of their different technologies. Now there are several technologies. By using that technologies from a huge data set, now we can integrate that data set in terms of your applicability, and we can single-handedly manage that large-scale climatic data, satellite data efficiently by generating your actual interventions in each and every field and each and agriculture allied activity for your enhancing your agriculture strategies. Okay, so what is why the AI matters? It will improve the crop yield prediction. It will enhance your climatic risk forecasting. We can generate actual AI models by using how you can prepare the climatic models with integrating AI, and in terms of how you can generate the management farm management decision at your farmer field level. We can demo a actual farm decision management systems in our practical examples. By combining that crop model data, climatic data, and machine learning agriculture, we can move towards more accurate, adaptive, and climatic resilient farming system. So, just a little bit of information about AI and machine learning. Uh, we all know machine thinks and solve problem like humans. That is the AI. Like we have to train a machine by feeding their data. We have to prepare their own food by incorporating data set to that machines. First, we feed to a machine a particular data set. By inculcating the, you can feed that data. We have generate the different kind of data set by using that machine. Okay. After feeding that machine different data set or large data set, now you have to train your machine to learn from your feeding data sets. Now you have trained that machine by learning your data set without being explicit to your program. Suppose you have to feed it 10,000 photos of a plant that is having yellow rust disease occurrence in wheat crop. Okay. After feeding that photos to a specific module, you have tried to discover different angle of that symptomatic plants of your yellow rust. After all the information pertaining to the yellow rust, you have tried to feed your each and every aspect of, uh, of that module you have developed. You have to learn from data sets. After incorporating all the information in your machine, now machines start thinking about and solve the problems by identify by single pictures you can depict or upload that picture. He will tell us about there is a partial occurrence of yellow rust, there is a severe occurrence of yellow rust. You can manage that yellow rust by adopting that advisories, or you can go for spraying of propiconazole spray at the rate of 100 ml using that spraying machines. So what you have developed, you have to train the machines by showing different 10,000 photos of your yellow rust by learning that computer programs and generate a equation that is capable to think just like a human and trained just like a machinery program, and you give a exact information about to the depict your actual farmer field problem you have solved using that data set. Okay, this is a generalized example how the AI and machine learning will work. After that, incorporating your old algorithm and predictions of your module, you have fed 10,000 photos of your single machinery programs. You have prepare a single machinery program of AI or machine learning program. Now you have to feed other machineries data by adopting the exact congenial environment for occurrence of that onset of yellow rust. By incorporating information, you have to feed the data. If the RH is more than 75 to 80%, and your temperature is 25 to 28 degrees Celsius, that made the trigger for the occurrence of yellow rust in wheat. That you have trained your machine learning program with your algorithm based equations. Now you have to advance your program with the use of different algorithms. Now you have to witness second conditions is there also there. You have if the prevailing conditions showing that occurrence of heavy rainfall, that may be the trigger the occurrence of the that yellow rust, may be the chances of the prevalence of yellow rust. Third condition you have put that if any farmer they can visit their field and he can sense there is a yellowish type of color is streak out from the crop, that may be the chances of the occurrence of yellow rust wheat. After their insight of different types of data set, now you have to program your data by inculcating the different technologies in a single program in single neural network. Now you have prepared a AI based technologies, that is you have to start feeding out the machine learning algorithms by forwarding the pass by the producing the input data. After that, you have to rectify their errors from also by if if there is certain kind of conditions that may be the preval, that is conditions not assessed by your models, that may be the loss function. Now you have to remove that, or you have to erase that images that is a not stable for identify that yellow rust in wheat. Now you can compare the predict output with your actual data set that you have inbuilt your in programming data that you have prepared for the disease detection methods of your program work. After that error losses, you have to optimize your model with the integration of the different error minimizations. You can use the different agriculture tech or different AI technique, that is the sport vector regression. These all are the advanced version of algorithm works which are directly enhance your accuracy of your develop neural networks of your machine learning. So these are the machine learning technique. Firstly, you have to study the problems, like we have studied the problem of yellow rust in wheat. After that, you have collect the data. You have collect 10,000 images from different field conditions. Then you have prepared the data preparation in different types of formations. Then you have assessed the conditions, climatic conditions, soil conditions, or different type of crop management conditions. Then you have to select the model of your region specific data. After that, you have covering the entire northwest India, that is pertaining to the severe occurrence of yellow rust in wheat. After, you have to train that AI and machine learning module in terms of building and training. Then you have to evaluate the model, either these information we have built in your module, is it correct or not? If correct, then you have to tune that model, and after that you can deploy that model in farmer fields for their technical decisions regarding each and every aspect of your crop performances, crop estimation, crop area estimation, crop yield estimation, if any types of remote sensing estimation, if any types of salinity estimation, if any types of flood assessment, any types of drought assessment, each and every part of agriculture that may be get benefited from that machine learning technology. So this is the prime area from where you can develop your machine learning technique, climatic smart technique, from where you can act your data set in farmer field. After that, that how that farm senses IoT will work in terms of technologically, either they are work actual in farmer field level or not, in terms of your soil sensor, in terms of your weather sensor, in terms of your animal husbandry aspect, in terms of your a brood section of a broad dairy animals, from where and dairy growers that can monitor their health in terms of your pandemic scenario, in terms of their other things. He can also assess each and every part using IoT, using that technologies also. Then how you can, from where you can get the all the informations, you can get different types of agrometeorological data sources you can assess for the AI models. From these all the website, you can get the prime data set for your different type of deployment of your algorithms, machine learning technologies, from where you can develop, you can desired results you can get from that data source. The Prime Institute of Weather Information, that is IMD in New Delhi, you can get all types of data from where National Meteorological Observation of India. You can visit that assess from in terms of your variable rainfall, temperature, humidity, in terms of automatic weather stations, in terms of National Data Science Portal NDC, that is run by the IMD Pune. NASARTHO data, you can get each and every aspect of satellite-based global weather data. You can access all the data set from your that URL. You can also access the Earth atmospheric data using NOAA website, that is give the information about the worldwide global historical weather and climatic reports in terms of precipitation, in terms of temperature, in terms of wind. You can assess using that website, or you can assess the URL. You can also assess different grid data. Now you have to listen to each and every students from our lecture. Grid means you have to select your grid data. Means there are several grid which are divided by entire India. If you are studying, someone is from the Kerala, you can use ERA15 data set from your South Peninsular data, from derivation of that data using that variable. Suppose Ernakulam district is there in Kerala, you can use that Ernakulam data by using the CDS site Copernicus, and you can assess that data set on your local design, and use that data set in your UG research, PG research, and PhD research. Same kind of data set you can use NASA Global Precipitation Mission data. You can also that grid data set by using that URL. That is the free site NASA. You can access that entire data set free of cost. The last one is climatic hazard group, that is CHIRPS. CHIRPS also run by the IMD, and you can get the long-term rainfall data set, but that CHIRPS is, I think that is paid. That site may be the paid, but if you are studying in any state agriculture university or ICR center, by writing just an email to that website or that IMD center, by writing a simple application, you just write your institute name and you can just draft the application and saying that we have required that long-term weather data set by using that research work. Please provide the data set. Then they can provide you that region data set, and you can use your research work. You can use that research trials by integrating that work in your agriculture climatological long-term data set in your research work or core work also. So these are the some most advanced types of unmanned aerial vehicles. Now our government more precisely focusing on deploying that drone area. So I can just put that slide, how the unmanned aerial vehicles that help our crop monitor crop health in terms of their spatial cameras. You can use the plant stress early, you can create the 3D maps, you can use the targeted spraying. Targeted spraying generally mainly using precision agriculture from areas that is the much capable for doing that precision agriculture used by the comprising the GIS, GPS, and integrating the remote sensing technologies. And nowadays, the agriculture can move towards assessing the canopy temperature in terms of your list data. You can assess the plant water stress in terms of crop water stress index, drought damage, storm damage assessment. There are several ways you can use that drone purpose areas. There's a similar kind of agriculture drought, but it requires a heavy agriculture mechanization in terms of autonomous tractors, robotic weeders, automatic harvesters. Now these are the some common machine learning technique. You can use your UG program, your PG program, PhD program. These are the generalized machine learning technique from where you can learn the technologies. These are the just simple language technology by you can learn that methodology by using the label data. You can learn or develop the relationship between input and output, and you can use that machine learning technologies for collection of historical data, data set input variable, generation of logarithm. The main aim of that supervised and unsupervised learning, it's just basic of your machine learning technology. By just browsing your YouTube, you have to just write the I have to learn supervised learning. By indicating there are several videos, you can learn the some common basic scenario of supervised learning and unsupervised learning. Both the learning will start your curriculum of machine learning. Nowadays, each and every aspect of your climatic science, agriculture science, breeding science, speed breeding, insect and pest and pathological aspect, horticulture aspect, vegetable aspect, agriculture uh, and agroforestry aspect, each and every allied activity of agriculture is now shifting towards that machine learning technologies. So you can generate that kind of machine learning data set. You can strike out both the supervised and unsupervised learning technology by meet out your goal from your research area, from your different type of crop examples, by detecting that differences also. You can use the technology by generating both the supervised and unsupervised technologies. So how that both the learning using agricultural methodology First is crop yield analysis. We can use that both the learning, you can use that both the supervised and unsupervised learning. You can generate weather forecasting, pest and disease prediction, drought modeling, soil and crop monitoring, and climatic pattern analysis. So all the informations you have pertaining by the supervised and unsupervised learning, that is integrating into the data-driven agriculture science, that is ultimately you can reach out your climatic smart agriculture technology. Now we have moved towards some more advanced state of your machine learning AI technology like ANN. ANN is just like our mind. ANN, first you have trained our model to just like our brain. Just I have given a simple example to you. Suppose I have staying in a local colony and there is a nearing a station over there. First, I have visited from my hometown to station by using the simple motorbike. First visit the motorbike. After then, I visit by using car from hometown to station. Then I visit by walking in distance from my hometown to station. I have visited 3 times from my hometowns to railway station. Each and every time when I visited from my hometown to railway station, I have witnessed there are several types of things during that distance I have covered from my hometown to railway station. Each and every times I have gathered several informations by detecting there is a kirana store, by detecting there is an other type of store, and I have collected all the informations from my hometown to railway station. After the span of 3 to 4 visits, my ANN network will detect each and every aspect of your hometowns to railway station. Now there is no need to travel from that area from hometown to the railway stations. Now your ANN network will enable all the informations and you did not travel from that area to your railway station. The same kind of example will applicable in the ANN. It will also inspired by the human brain functionally, and each and every structure of your neural network will consist by the each and every related aspect of your hometown to that railway station. This is an advanced science of your climatic science scenario that will helpful in our upcoming scenario. That is also in classical example of deep ANN networks. And then that deep ANN networks will decide the our main aim of data-driven agriculture in terms of your precision agriculture. Means that data-driven agriculture is prepared a personal diet for every plant in each field by using or by integrating remote sensing, GIS, GPS, traditional agriculture, integrating the climate smart agriculture, integrating the each and every aspect of your farming from their emergence to up to the harvesting of your crop. So, by adopting a personal diet of human person to adopting a personal diet for every plant, you can generate entire scenario of your cropping system from old way to the new way by enhancing our agricultural production in per unit level or farm field level. So the same AI will create your prescription map just by giving a doctors. We have prescribed our farmer field level by applying the precise way of amount of fertilizer, water, nutrients, seed, and each and every aspect of your crop production. You can manage your agriculture produce with the help of your climate smart part. Means you can You can incorporate your one size fit alls. That means you're inefficient, expensive, and pollute underground. You can make just like you have to work as a surgical strike by incorporating your saving of your hard saving money, hard saving your available resources, hard saving of your climatic expenses, hard saving of your reducing the impact of climatic shocks. You can enhance your overall yield and you can protect our environmental scenario by adopting the climatic resilient agriculture technologies in terms of your climatic smart agriculture technologies. Similar kind of your adapter for your crop, you can generate the a similar kind of technologies you can incorporate at the farmer field level. We can forecast the harvest also. That entire scenario will enhance in terms of your imagery, weather forecast, and historical weather data. I have already discussed how the AI solutions will combine that entire scenario of your cropping patterns to enhance your agricultural produce in a recent scenario. uh, by adopting the technologies, you can enhance your resilience in farmer field level along with your animal husbandry. Because I have worked in 3 and almost 4 years in National Dairy Research Institute, in Dairy Institute, from where I can learn a lot of scope is there to enhance our agriculture produce in terms of your agriculture animal husbandry part. There are several innovations which are under pipeline by enhancing our animal produce in terms of your meat purpose, wool purpose, milk production. We have witnessed a white revolution by incorporating the AI science in terms of in your dairy production also. Now, a single kinds of a smartwatch also developed by a scientist that is assessing your IRT temperature, that means infrared temperature of your animal or your cattle by assessing their stress condition. Is there temperature stress? Is there neutral stress? Is there disease stress? Or any kind of illness before assessing the physical symptoms of ES. If you have heard of more than 200 or 300 of animals, you can assess the entire animals herd by incorporating the smartwatch in entire dairy herds by assessing their breeding times, by assessing their lactation period, by assessing their actual milk produce, by assessing their vaccination purpose, by assessing their proper nutrition also. So these all are the AI and data-driven agricultural practices. So now we have put it all together in terms of precision farming, pest and disease detection, yield prediction, smart irrigation, livestock management, and automation and robotics. Each and every aspect we have required a holistic approach. We does not carry a single aspect to lead a profitable farming. We need to a holistic approach by integrating the agriculture, by integrating the animal husbandry, by integrating the dairy, by integrating the horticulture, vegetable, forestry, environmental science, biochemistry. Each and every aspect we have to put together in all in scenario. I have shown a AI case studies in agricultural meteorology. It's an hour experiment. We have developed that model from a long-term data set of from 1982 to 2025 from HAU data. We have generated that model using that four technologies. That model is developed by me and my other colleague, and that data is accessible for we have used four equations: lasso regression, bridge regression, support vector regression, and lasso support vector regression. These are the four models. We have used that four models in the form of machine learning technology, algorithm of AI, and we have developed that R score almost 99. That means our prediction value, that R square means coefficient of determination. That means your how the model is capable or what is the accuracy of your model. And we have compared both the yield. It almost identical, and our model is robust and predict the farmer field at farmer field level. These are the algorithm we have developed in different type of equations. As you have seen, there is a close remarks on both the each and every models, rigid equations, lasso regression, lasso SVR model, and SVR models both also. These are the machine learning and similar model technologies. It will also assessed by me and our co-workers, but our major portion is not our mind. That is GE et al. But we have also we can use that kind of experiment at our field condition also. These are the modeling reference data. You can also generate that data. These are the simple workflow. You can use that kind of data in farmer field level. So these are the higher main, as I already told, we have to enhance our productivity, we have to minimize our resources, minimal use. Ultimate aim of our climate smart farming is to increase profitability by minimizing the cost of cultivation. We have to enhance our overall crop yield. We can generate the more income, and we have to prosperous our more farmers, particularly small and marginal farmers. And by adopting the sustainability, we have to we have to balance our environmental systems. We have to manage our each and every environmental resources also. These are the cycle of the growth, how you can invest in tech, data you can assess, then you have to make smart decision, you can increase the benefit, and these are the some pro and consequences also. Each and everyone saying AI and machine learning is good, but there is also a measure of obstacle regarding their applicability. It requires a high initial cost because drones and sensors are inexpensive. We have to require a sound internet connectivity because majority of the Indian conditions are like reliable internet connections. Poor data set we have to train our farmers by more proficiency, more technological sound. We have to generate the more technological development for the small farmers by using the our government initiative and flagship programs. And we have to assess each and every farmers adopt that technologies because if we have to ensure no farmer is left behind. And the big question is how we can that smart farming accessible for farmers which is having 2 acre land. So a digital dawn for the Indian farms we have to require our government initiative like to achieving that data by achieving the goal of doubling farmer income by incorporating the technologies, by incorporating that climatic smart agriculture technique. We have to tailor the solution by unique challenges. And there is also a key fact also, as we all know that India has the world's second largest agri-tech startup ecosystem because it will works for more proficiency in terms of their farm of 2035. We have to go for the vertical farming. We have to grow the traceability blockchain, AI farm advisor, gene editing and AI. These all are the roadmap of the sustainable production systems in terms of the 2035. So guys, the future is in your hand by adopting that agriculture data scientist, drone pilot analysis, AI and machine learning, robotics, agri-tech entrepreneur. Each and every part will assess. You have to use that smart farming, the AI, machine learning, IoT that make agriculture more precise, more productive, more profitable. It's a powerful solution to biggest challenge in terms of your food security. We have to mitigate climate change and climatic source as farmer field level. We have to more adapt towards your crop and livestock. It's not Haryana, it's not India. We have to just an option, not a traditional condition. We have to act for the future conditions. These are the journals QR code from where you can get the some good quality of application from where you can get the information about the weather forecast. The first one is dedicated for the Haryana farmers, but you have to assess Meghdoot, Damini, Umang, rain alarm, Mosam, each and every different type of QR code. You can download that applications, you can get the you assess the farm-based advisories at your own region from your entire Indian conditions from you. Either you are living in Leh, Ladakh, if you are living in Tamil Nadu, if you're living in Andhra Pradesh, each and every continent's covered by that different types of apps. So that's all about from my side. You can ask is from any doubt or questions, any query, any suggestions, and anything you want to say from that session. It's hard privilege to share my views, to share my express my words. Anything you want to share, you can discuss, you can assess from my side. You are most welcome. Hope it will be benefited from you. Any question that you may be asked from my side.
Thank you very much, sir, for your insightful and informative lecture. Your valuable explanation on agrometeorology and climate smart agriculture has truly helped us in understanding the importance of weather and climate in making the better agricultural decisions. We sincerely appreciate you for sharing your knowledge and experience with all of us. Now, we would like to open the floor for the query session. Participants who have any queries or any clarifications may kindly text their questions in the chat box. So, with your permission, shall I take the first question?
Yeah, sure, ma'am, please.
Yes, sir. I'll just take it. So, the question is from one of the participant, Praveen Kumar. So, the question is, what is the level of improvement in accurate prediction of weather and climate patterns by the meteorology tools? Say from 1990, 30% and 2020, it is 70%.
If you have checked any models, or if you have checked any type of your programming language, either model, the most reliable range of your level of agreement is 15% of level of agreement. If your model value is showing less than 50% of level of agreement, that means your crop is in overestimated, your crop is in good agreement with the field level data, and your crop is in acceptable limit. If your level of agreement is more than 15%, that means your model is not in good agreement. You have to recheck all your data set, and you have to firstly check your calibrated data, and then after you have validate the desired result output from your actual weather data sets. So level of agreement is less than 15%. It's not more than that. Hope the answer will by the participant may be asked by the Parveen.
Yes, sir. It was very much clear. Thank you for that, sir. Now we'll be moving for the next question that is from Kavneet Singh, and he is from SKUAST Jammu, and he's asking that, mm, sir, as you said, there are very less operational holdings, means there are almost marginal farmers in the country for adapting this climatic smart agriculture, which is economically not feasible for them. Apart from making farmers group in this situation, why don't we make such laws or policies for maintaining the environmental problems instead of adopting this? What is the opinion on this? He's asking like that, sir.
There are several kind of challenges faced by the small and marginal farmer. Although the government is also working on their welfare of that farmers, but main thing is that we have to develop that policies, or we have to frame out that policies that is more desirable for the Renford regions, because in Indian conditions there are almost 75 to 80% Indian continent is focus toward the rainfed regions. So we have to frame out that policies, we have to frame out that technologies that are resilient for that rainfed regions. And we have to incorporate that technologies that are much accessible at farmer field level. And we have to a little bit of hesitation of adopting the technologies also. So we have to minimize that bridge between the farmers and the scientific fraternities. We have to minimize that gap between scientists and farmer field level. So that is the best way to fill out that gap by adopting climate smart technologies to farmer field levels by incorporating the government policies and flagship programs. So in my opinion, we have to integrate both the regions in terms of your farmer policies, government policies, flagship program, and the major positive perceptions from the farming community also. So that may be the best way to meet out that goal from the farmers and the institute also.
Thank you for
Hope
that, sir.
that's clear.
Yes, sir. I'll just confirm with him, sir. Sir, we have another question from our participants. That is also the repeated one from Aditya as well as Ayan Gowda. So, sir, did AI in agriculture is not so useful for Indian small farmers, or else if it is useful in agriculture sector, how? They're asking like that, sir.
No. There the AI is useful for the all the farmers, but our main targeted audience is that we have to work on that kind of technology that is used vastly and that is adopted by the majority of the farmers. In our early initiation of our presentation, we have shared the information that our majority of the farmers are small and marginal farmers. So our technology that may be the more eco-friendly, that is the more accessible for that farmers, that is small and marginal farmers. AI and machine learning technologies that is accessible by each and every farmers. Just like weather forecasting tool, it is accessible for the small and marginal farmers and and those farmers who have large लैंड होल्ड्स जिनके पास more land available options हैं. So each and every AI and machine learning technologies is helping hand for the farming community, but it is applicable more benefit for the small and marginal farmers. So my request and my recommendation is that we have to develop that technologies that is more friendly to each and every farmers, not the small and marginal farmers. We have to target each and every farmers of entire country. I hope the question is clear from my side. If something is else, you maybe ask that.
Yes, sir. I'll confirm it from Aditya as well. Sir, we have another question from Nisha Kumari. Her question is, how a farmer can protect the crop from the acid rain?
Acid rain.
Yes, sir.
Generally, acid rain is mainly prevalent by the combination of the two, uh, that is pH is less than 5 and HCl and H2SO4 are the prime two solutions that is mainly reactive agents for the acid rain. It will diminishing the coloration. It will also affect the discoloration of your monumentals and discoloration of your crops and negatively affect your crop growth and productions. For the better production of the acid rain, you have to use more greenery. First one is you can go for the afforestation. Second one, you can minimize your factory outlet or your industrially and sewage treatment plant, that is reduce the concentration of HCl and H2SO4 outlet. The majority of the agrochemicals, the majority of the industrial expulsion that is emitted by the different kind of agriculture waste, you have to minimize, or you have to treat it that waste water efficiently by decreasing that concentrations, from where you can reduce the chances of your acid rain treatment plants, because it's not depend on the single entity. It will depend on, there are many factors which are affecting the acid rains. So, like Agra, there is in Taj Mahal our monuments that each and every year it will deteriorate due to the prevalence of acid rain. By incorporating several measures by Government of India and Uttar Pradesh government, they will try to minimize the impact of acid rain in Taj Mahal monument, by adopting these technologies. So I hope that the question is maybe the answerable, and the answer is that
Yes,
hope
sir.
it is clear now.
Thank you for that, sir. Sir, we have another question from Riju Pandey. His question is, sir, for detailed and informative session, which is the most practical climate smart technique that small farmers can easily adopt, especially in UP region?
In UP region,
Yes, sir.
although there is in UP region, there is a more severity of climatic shocks in terms of erratic rainfall behavior, and in terms of poor adoption of crop weather calendar, and poor adoption of agriculture technologies. So my first uh, advice or first suggestion may be to the UP farmers and their related region. Firstly, they have used the agriculture based agromet advisory services for their crop planning, for their crop management strategies, and sustainable production management systems. As per the agromet advisory services, they can plan their cropping system, they can plan their crop, they can, each and every aspect they can decide as per the weather-based agromet advisory services. Secondly, they can plan their entire growing season with the help of Planning Commission of India and their district contingency agriculture DCAP. They can browse DCAP with the help of district contingency agriculture planning. Each and every district contingency planning is available on Google website. You have to just type DCAP for UP region. You can get entire scenario from your region, from where you can get the contingency planning of your each and every crop. I hope the answer will pertaining to that question.
Yes, sir. It was very much clear. Sir, we have another question from Praveen Kumar itself. So his question is, how can I generate a sustainable crop module for 1 acre dryland farm which gives optimum income and sustains a family? Do you have a sample that can be shared with an explanation?
There is that kind of approaches, you have to go for the holistic approach. You can go for the IFS, integrated farming system, and that is a much pertaining to your question. Uh, Although there are several types of IFS model available in entire Indian regions, by adopting that IFS model that is dedicatedly prepared for that rainfed region, or that your prime region, you have decided to that IFS model. By adopting that IFS model, you have to use one waste from entrepreneur to use second as their key input in terms of holistic approach. Like, you have harvest the crop, and you can use that harvestable produce to the pasture of your animal husbandry crop animals their feeding requirement, and their byproduct in terms of their sewage, in terms of their, you can use that sewage in terms of your production of biogas plant. And after the biogas plant, you can use mud or slurry as a javik, you can go for the organic farming. So it's an holistic approach in terms of your IFS. You can generate that kind of farming system by employing the minimal resources. You can generate the maximum production in your that may be the suitable from your objective. Hope it will meet out your entire scenario of your question.
Sir, actually, he is asking that whom should I connect? Like, whom should I contact with
You
for the
should
crop
contact your
module?
nearest Krishi Vigyan Kendra. If they are not capable, then you go for the district agriculture officer of your nearest area. If both are not capable for doing this, you can go for the nearest state agriculture university. Or otherwise, if you could not get that from where, you can contact us. We will provide the information from you. There is no need to worry about it. You can get the exact information from where you can learn, or you can plan your experiment as you have thinking about in your long-term plan.
Yes, sir. Thank you for that, sir. And now we have another participant, Kavya. So the question is, sir, what are the challenges in implementing CSA in our country? What are the recent research developments in agrometeorology for future research priorities that could be done in climate smart agriculture?
Sorry, man, I got just repeat. Can you CSC means I could not understand. Can you repeat the question?
Yes, sir. What are the challenges in implementing CSA in our country? And what are the recent research developments in agrometeorology for future research priorities that could be done in climate smart agriculture? Sir, CSA means, I guess it is climate smart agriculture.
Yeah,
Yes, sir.
I get it, ma'am.
Thank you.
CSA, the main aim of that CSA, you can plan each and every parts of India, but the majority of the major problem is that you have to convince the farmer by adopting that CSA technology, because farmers have limited available resources in their farmer field. The initial cost and investment a little bit of higher from the traditional agriculture practices. You have to convince farmer from your strong point of view. You have to start that practices in a limited land scenario. You just not need not to convert entire scenario in a single year to convert climate smart farming technology. You have to start a little bit of farming. After that, you can expand from your entire area. First one is that. Second is there is an initial higher cost of installment that may be the higher. You can arrange that investment from the partial form of subsidy, and you can align with your KVK, and you're aligned with CSC custom hiring centers and government initiative institutes. By joining that institute, it will helpful for your small steps to adopting that climate smart technologies. Okay, after that technologies you have adopt, then you expand the technologies into a broader scale. Just an example of that, in Haryana condition, in initial condition, there are almost formation of 70 villages that is entitled climatic smart villages. That is a classical example of BISA and SIMIT, that is a long-term trials you have studied in your Google, and you can access the information from several research papers. Initial condition, they have worked on about 60 to 70 villages, climatic smart villages, that is working on the aspect of climatic smart technologies. And you can surprise that they have adopted more than 60 to 75 technologies. By adopting these technologies, they can improve their overall yield production up to 60 to 70%. So it is showing that after adopting the technologies, farmer can enhance their yield and production up to 60-70%. Again, there are some limitations. Firstly, you have to start a small scale. Afterwards, it will enhance in a broader scale with the association of your nearest agriculture officer, KVK, state agriculture, ICR centers. Each and every part you can align with that. So that is the answer from that participant, ma'am.
Yes, sir. Thank you for that. It was very much clear for the question that they have asked. So we have one repeated question from few of them. Like it is different and like they have framed it differently, but the question is same. Like it is like, what is the use of adopting the technology if the produce is not having markets? How a farmer can mitigate the burden occurring due to the technology, but not as getting in the local market? These technologies are costly, and the small farmers cannot pay for that. And related to that is, how should we develop machine learning and AI models in prediction of agriculture, because the farmers are not aware of that in large amount, and how to integrate, like they're asking how to transform from from the normal one to the AI. Yes, sir.
In our slide, I have told them that there is a smart farming. That means we have to integrate all the fields for that smart farming. Just an example of that, a single farmer that is producing garlic, each and every time they have cultivating rice wheat cropping system, they can get benefited from 1 acre approximate 50 to 60,000 per season. Okay, after adopting the climate smart technology with the market oriented smart farming, and what kind of demand is more prevalent in market, so he choose that cultivation of the garlic crop instead of wheat crop. And that climatic smart technologies, by adopting in garlic crop, he can earn up to 3 to 4 lakh. It's a practical example of our farmer in Karnal region. In a single season, he can earn up to 3 to 4 lakh, but they have to be smart as per the market oriented demand. With the incorporating climate smart technology along with it, if the farmer is a small or marginal farmer, then there is no need to worry about it. They can they can uh, they can use the technology with the help of other agriculture officials. It's not a miracle, or it's not an magic wonders. You have to spread out, and each and every aspect will go with the flow. It's a technology. It will take time from slow to the up to the reach to the end end part of the farmer. You are just an example of laser land leveling. At the time of laser land leveling in 1980s, a single farmer cannot adopt the technology. He is saying our soil can be deteriorate, and our soil could not get much fertile for production of the different crop. And ICR scientists, state agriculture scientists, each and everyone is convincing to the farmer, sir, this is the most advanced technology. It can equalize your entire farmer in a similar form for the precise use of your fertilizer, precise use of agriculture application. It will enhance your agriculture production, but each and every farmer should not adopt it. After the adoption of single 3 to 4 farmers, they can benefit from laser land leveling. After that onwards, nowadays more than 95 to 96% laser land leveling technologies was accepted throughout the world. That is the most accepted technologies in the form of climatic smart technology. That is the climate. That is a part of climatic smart agriculture technology. That is the way of different type of adoption of agriculture technology. You can't say we have to convince our farmers. We have to provide the practical results to the farmer field. After that, he can convince, he can adopt the technology at the farmer field. So I hope that is the much pertaining to the clear answer of your question.
Yes, sir. It was very much clear. Sir, we have couple of questions.
So, yes, ma'am.
Sorry for interrupting, sir. Sir, we have a couple of questions still. Shall we continue with them?
No problem. Continue.
Yes, sir. Thank you for that, sir. So the question is from Atul Kumar. So there are few sub questions like around 3 to 4. I'll be asking one after the other. So the first question is, how can farmers reduce greenhouse gas emissions through the climate smart practices?
By adopting the carbon sequestration approaches, you can integrate your agriculture crop scenario. uh, we can generate carbon sequestration technique. See, what is carbon sequestration? We have to capture CO2 in an atmosphere, and we have to store that CO2 in a long term in terms of your sequestration purpose. Either they are in geological sequestration or they are terrestrial sequestration. Terrestrial means you have to cut the crop and you have to store in a soil to enhance your soil organic carbon. It will the main aim of your carbon sequestration is to capture CO2 from the environment, and we have to uh, re-establish or reorient to that soil organic carbon into the soil. So that is the basic approach for carbon sequestration. You have to grow more vegetation. You have to go for more afforestation. You have to grow more trees. That is the ultimate aim of your purpose of your reducing the CO2 concentration in terms of your atmosphere, and it will decline the your greenhouse gas uh, emission of concentration. That is the best way to mitigate that CO2 concentration in an environment. So that is the most convenient and most feasible way of sequestration and CO2 carbon sequestration technique.
Yes, sir. And the second question is, which climate smart technology has greatest potential to improve productivity, sustainability, mitigation, and adaptation at the same time in Indian agriculture?
CSA, climate smart agriculture, holistic approach in which you can include the carbon smart, nutrient smart, weather smart, fertilizer smart. Each and every substances you have to judiciously use as per their requirement, as per their uses, or as per their schedule frame of their crop growth and development. You can use the CSA as the best way to meet out your each and every part of your better crop growth and development and better your estimation.
Yes, sir. And one last question from Atul Kumar was, what research gaps still exist in adoption of climate smart agriculture technologies in country, and how CSA contribute in the long term of soil health and carbon emission?
Yeah, that is a good question. Oh, by adopting, it's it's not happening on a single agriculture entity. We have to integrate all the agriculture application in a single frame. Like if we discuss, there are three pillars of CSC. We have to precise, predict, we have to use the resources precisely, and predictability and profitability. 3P will answer your all the questions in terms of CSA. We have to act precisely, we have to act profitability, we have to act predictability. If our main available natural resources we have used precisely, and we have to act AI, machine learning, CSA, climate smart agriculture technologies, integrating all the technologies for the predictability, and precisely, ultimately, it will lead to the profitability. And that will fill your gap between farmers, educational institute, government policy planners. It will integrate in a combined triangle form. And it's a holistic approach to feed out each and every 1.5 billion people of the worldwide. And we can also meet out your targeted human populations with a better production of your food crops, fruit crops, vegetable crop, and each and every agriculture and allied activities. So that is the best way to make more profitable, more resilient, and more resilience toward the negative agriculture or abnormal weather conditions के हिसाब से we can prepare that crop line. So that is the ultimate aim. By adopting that technology, you can make farming more profitable, more resilient, and more economic. So that is my answer for that question.
Yes, sir. Thank you for that. Sir, the
Dhiman,
participants are asking for is CSA available in village level to guide any like to any farmers to guide? Is there any availability in the village level?
yeah, there are several technology I have seen my PPT also. You can with the green seeker, site-specific nutrient management. There are several technology, weather-based agromet advisory services, or several technological operations I have discussed in PPT. You can assess over there, and there are several technique you can use. It is in the presentation we have discussed in detail. Okay. Ma'am, we have discussed our technologies earlier. There is no need to, I think, answer that question.
Yes, sir. There is one last question.
Ma'am,
Sir, sorry for interrupting. Yes, sir.
you are in mute, ma'am. Please go ahead.
Yes, sir. Thank you for that, sir. Sir, there is one last question for today. That is from Siddharth. Actually, his doubt hasn't been cleared. So he's asking again. Sir, as we are from agriculture background, so how can I build or develop ML and AI models for prediction in agriculture and integration of AI ML with IoT, sensor and weather forecast?
By using the data-driven sciences, you have to collect the long-term data set of your region. After that long-term data set equations, you have to use that data set in terms of your soil data, crop data, management data, and using the AI and machine learning language technique, supervised and unsupervised technology, and that technologies will build a simple equations. That equations we have used in terms of your regression equations and vector support vector regression equations, and there are several Python programming language you can generate which is desired or which is easy to understand to you, and that equations you have can interpret as per your core planning of your research goal, and that goal you have decided as per your objective of your research. After that, long-term data set, weather data, soil data, crop data, management data, you can integrate and found useful in terms of your cropping pattern, in terms of your desired action. What either you are predicting your crop yield, either you are predicting diseases stress, insect pest attack, whatever you have want, you have developed your own your action as per your need. So that is the answer.
Yes, sir. Thank you for that, sir. Like maximum number of people are asking that what are the career opportunities, sir?
In
Career
in
opportunities. Okay,
in
in
CSS,
yes, sir.
there are there are several types of career opportunities. First, you have works as a climatic scientist in majority of the IITs and majority of the agricultural institute. You can start as a career as agriculture meteorologist, as a scientist, as a weather forecasting. You have to act as a data analyst in Indian Institute of Remote Sensing. You have to act as a data in terms of your remote sensing persons, like the detection of your flood assessment, drought assessment in NCMRW, National Center for Medium Range Weather Forecasting Institute, IITs. You can also join as a uh, scientific programming institute in IARS, Space Application Center, Ahmedabad. You can also act as a career in forecasting as a meteorologist in India Meteorological Department. You can act as a data interpretation and AI and machine learning technology in data analysis in SAC, Space Application Center, Ahmedabad. There are the several ways you can contribute in geographically, remote sensing institute, GIS and GPS, as a meteorologist, as an agriculture meteorologist, as a scientist, as a ARS, Agriculture Recruitment Scientist Board, as a professor, as an assistant scientist, whatever role you have chosen, whatever field you have chosen, either in a vegetable, either in a horticulture, either in a plant breeding, either in a animal husbandry, either in a fisheries, either in a whichever professions you may be the chosen, you can accumulate, you can align with your data scientist from wherever, whatever your long-term goal in your life. So I think that is the clear from my side.
Yes, sir, it was very much clear. Thank you for addressing all our queries, sir. Now I request Ajay Kasana, sir, the Chief Secretary of Agri SAARTHI, to share few words.
Thank you, Chatrisa. Jai Hind. So thank you so much, Dr. Yogesh, for such an in-depth and detailed session. Like you have oriented our participant about the different climate smart techniques available and in which domain they can work in their coming future. So really, it was an insightful session, and we are blessed to have you today as our speaker for our participant. Thank you so much, Dr. Yogesh. And
Thank you. Thank you.
thanks to all the participants also for patiently listening to him. And he have also told you about different career opportunities available after your degrees and your MSc and PhD. So we are really, and I can say that we are blessed to have you, Doctor. Definitely, we look forward for such more detailed sessions from you. So thank you so much to all the participants, Dr. Yogesh Kumar, and to Ms. Chatris and Dr. Vijay. Thank you so much. Jai Hind.
Thank you so much. Thank you.
Thank you for your grateful words, sir. On behalf of Agri SAARTHI team, I would extend our sincere gratitude to Dr. Yogesh Kumar for delivering such an enlightening and informative session. Your valuable insights on agrometeorology have truly inspired us all, and it was very much valuable for sharing your words based on advisory services that have greatly enhanced our understanding how the scientific knowledge can support the sustainable and resilient farming. We truly appreciate your dedication towards research, teaching, and extension activities that benefit both farming as well as the community and the academic world. I would also extend the thank to all the organizers, coordinators, and participants for their enthusiastic participation and support for making the session successful. I request all the participants to kindly fill the feedback form on mandatory basis. As we conclude today's session, let us remember understanding today's climate help us in cultivating a better tomorrow for agriculture. With this thought, we look forward in continuing our learning journey in tomorrow's session. Once again, the heartfelt thanks to you, sir, for sharing your valuable time and knowledge. Jai Hind, sir.